Hey guys, so today we're going to be learning about Unit 1, Lesson 4, Velocity, Acceleration, and Second Derivatives. So, and to understand velocity, acceleration, and second derivatives, we must understand displacement, velocity, and acceleration. Displacement is distance and direction on an object which has moved from an origin over a period of time, d at t. Velocity is the rate of change of displacement of an object with respect to time. V at t is equal to d prime at t. Acceleration is the rate of change of velocity with respect to the time. A at t is equal to v at t, which is equal to d double prime at t. An example of this would be, suppose a particle moves according to the position function s at t, which is equal to 1/3 x cubed minus 2x squared minus 3x plus 5, where s is in meters and t is in minutes. So for question A, it says, find the average velocity of the particle over the first 10 minutes. So first, we need to sub in 10 into the original equation, then sub in 0 into the original equation. We do 0 and 10 because it says over the first 10 minutes, which means 0 to 10. So we do s at 10 is equal to 1/3 at 10 cubed minus 2 at 10 squared minus 3 at 10 plus 5. So to expand this, and we're left with this. So for this number, we need to multiply it by 3 to have a denominator of 3, which makes it easier to subtract. We're then left with 325 over 3. For s at 0, we need to sub in the x for 0. So 1 over 3 times 0 cubed minus 2 at 0 squared minus 3 at 0 plus 5. We know that anything times 0 is 0, so we can just cross 0, and we're left with 5. The second step is basically finding the average slope, which is y2 minus y1 over x2 minus x1. We need to use the values from step 1 for y2 and y1, and the values subbed into the equation. So we know that we found y1, which is this, and y2, which was 5. Then we have to find the x's, which we already know. It's 0 and 10. So sub these values into the slope equation. So we have 325 over 3 minus 15 over 3, because it was 325 over 3 minus 5. So we multiply this by 3 to make it easy to subtract. Then we do 10 minus 0. We're then left with 310 over 3 divided by 10. Then we flip 10, multiply it of its inverse, which is this. We cross out the 0, then we're left with the change of s over the change of t, which is equal to 31 over 3 meters per minute. For B, it says, find the position, velocity, and acceleration of the particle at t equals 0 and at t equals 5 minutes. So step 1 is basically finding the position by subbing t equals 0 and t equals 5 into the original equation. So we sub t equals 0 into the original equation, and we're left with 5 meters again. Then we sub in 5 into the original equation. We do the math, and then we subtract, and then we make this over 3, which is this basically. We'll multiply that by 3, 2, and then we're left with 125 minus 180 all over 3 is equal to negative 55 over 3 meters. So that's our position vector for s at 0 and s at 5. Then we have to find the velocity by deriving the first equation, because we know from the definition that v at t is equal to d prime at t. Then we sub in the time values that are given. To derive, it means f at x is equal to cx at n. Then f prime at x is equal to c times n x minus 1. So we take this number, bring it down, and then we multiply them. So to derive this, we need s prime at t is equal to 3 times 1/3 x. 3 minus 1 is 2, so that's squared. Then we bring this down and make this equal to minus 4x, because 2 minus 1 is x. then we know that this is actually to the power of 1. So we bring that down, and it's minus 3, and 1 minus 1 is 0, so this cancels out. And we can't even do this because it's basically 0. This is the derived equation. Then find the velocity. So s prime at 0 is equal to negative 3 meters per minute. We know this because this would be 0, which is just 0, and x would be 0, and then we're left with 3. So s prime at 5 is equal to 3 over 1/3 times 5 to the power of 2 minus 4 times 5 to the power of 1, which is just 5, minus 3. And we know that this all equals to s prime at 5, which is equal to 2 meters per minute. That's the velocity. Step 3 of finding the acceleration by doing the second derivative of the first equation, then subbing in the values. So we know that a at t is equal to v prime at t, which is equal to the double prime at t, which is also the second derivative. So we do s prime at t, which is the prime. To do double prime, we take this equation, or do the derivative again, sorry. So this would be the double prime. Now to find the acceleration, we just sub in the points given at b, for b, which is t equals 0 and t equals 5 minutes. So that's our time. So we need to find y, which is also s. So s double prime at 0 is equal to negative 4, because we know that anything times 0 is 0. So then we're left with negative 4 meters per minute squared. Then we have to do s double prime at 5, which is equal to 2 times 5 minus 4. So s double prime at 5 is equal to 10 minus 4, and then we know that this is equal to 6 meters per minute squared. Thanks for watching, and that's how you do velocity and acceleration and second derivatives. Thank you.